Okay, so you were given the task of integrating this generic function. It was the integral of 1 over a squared plus x squared, and then that taken to the 3/2 times dx. Okay, to go about this problem, what we have to do is trig substitution. Okay, so here's what we're going to do. We are going to say that x is a tangent of u. Kind of like u substitution, except now this is trig substitution. So x equals a tan of u. Dx is going to be a secant squared of u du. Okay? Because the derivative of a tan u is a secant squared u. Okay. So with that, if you look, I've got x squared. So x squared just becomes this squared. So a squared tan squared of u. So now we're going to take this and plug it into our equation. And then we're going to take this and plug it in for dx. So this function, let's switch up colors here. This goes in for x squared, and then our a secant squared goes in for dx. Okay, so I'm going to rewrite our equation, our integral here. So our original integral was 1 over a squared plus x squared taken to the 3/2 dx. Okay, so I'm going to make my substitutions now, and this becomes the integral of dx is now a secant squared u du, and then I've still got this a squared, let me make that a bracket, plus x squared is now a squared tangent squared of u, and then this is still taken to the 3/2. So this is just x squared. All of this up top is dx. Okay, so egads, that looks horrible. Let's work with our denominator and see if we can get that in something that is a little bit more manageable. So I'm going to rewrite my denominator out here, tan squared u. Okay, now looking at that, they both have an a squared, so I can factor that out. So that's the same thing as a squared times 1 plus tan squared of u. Now, if you are the trig savvy kind, you can think back to sine squared u plus cosine squared u equals 1. Well, what if I divided both sides by cosine? So I divide, or excuse me, cosine squared. Cosine squared. Okay. So sine squared over cosine squared, that's tangent squared. Cosine squared over cosine squared is just 1. And then 1 over cosine squared, are you ready for this? 1 over cosine squared is secant squared. So now I can take this and plug it in here. Okay, so let's simplify our denominator now, and I'm going to rewrite what we've got so far. So our integral was with our substitution, a secant squared u all over, I factored out an a squared, so that became a squared times 1 plus tan squared u, all of that taken to the 3/2. Now I apologize for my parentheses in parentheses here, but in a little bit of a hurry. Okay, now we said that 1 plus tan squared u was secant squared. So this becomes, I've still got a, oops, I lost my du. I've still got a secant squared u du, but now I've got a squared times, oops, times secant squared u, all of that taken to the 3/2. Now that is much more manageable, and I can simplify this quite a bit. So I'm going to take this to the 3/2 power. So up top I've still got a secant squared u, but now a squared taken to the 3/2 is just a to the 3rd power. That doesn't look very good. A to the 3rd power. Secant squared taken to the 3/2, whoop, really long bells. Secant squared taken to the 3/2 is just secant cubed u. All of this times du. Now this problem is falling apart. So a over a cubed, that's just 1 over a squared, and a is just a constant. So now, oops, I can just factor out 1 over a squared times the integral of, I've got secant squared over secant cubed. That's just 1 over secant, and 1 over secant, if you think about it, 1 over secant is just cosine. So that equals 1 over a squared times the integral of 1 over secant is cosine u du. So now all I have is the integral of cosine u du. The integral of cosine is sine. So this becomes, ooh, that looks a little dirty. Here we go. I've still got this 1 over a squared outside. And then 1 over, or excuse me, the integral of cosine was sine. So I've got 1 over a squared times sine of u, and then plus some constant c. In your problem, you've got limits of integration, but here I didn't have any limits. So it's just plus c. Now, I need to figure out sine of u. I need to figure out what that is in terms of my original variables. My original substitution was x equals a tangent of u. So tangent of u is just x over a. And think about tangent is opposite over adjacent. Opposite over adjacent a. And I have sine of u. Sine is opposite over hypotenuse, which, sadly, I don't know the hypotenuse. But this is just a triangle. So I've got the two sides, x and a, and I want to know the hypotenuse. That would be the square root of x squared plus a squared. That's my hypotenuse. That means that sine of u is opposite x over my hypotenuse, which is the square root of x squared plus a squared. So now, take that, plug it in for sine of u, and you are done. That means that our entire integral simplifies down to 1 over a squared times x over square root of x squared plus a squared plus c. That is solving an integral using Trig's substitution.